So we want to improve the fit, and we use more complex models or seemingly complex models to accomplish that, okay? And I'm going to ask you to explain your findings. So we're going to work on that today to get you started. And then let's see how much more help you need from me. All right, so I'm going to ask you guys to pull up the document that I shared with you already. How many of you feel like you need a review of regression? Put it in the chat. How many of you need a review of regression analysis? Nobody? Raul says yes. Okay. Anybody else? Okay, everybody. Okay. All right, so what I'm going to do, like last class, we just made a regression. How did you feel about that review? Or that exercise? I might just give you guys a regression. Go back a little bit. Did you follow what we did last class for the most part, or you didn't? Mm, okay. Okay, forgot how to interpret. All right. Okay, let's continue. And then what I'm gonna do is I'm gonna post. Well, let me, well, I'm so debating what I'm doing. Okay, so let's see. Hold on. I have some documents here. Well, I think the best thing is that you're going to go through the ZStat review. I think that's going to be good, but I'll also post some review of regression that I have. I think I gave it to you before, but I'll give it to you again. I have to find it. Okay, I think I'll just put those up. And I have some instructions too, but I don't, maybe let's just continue with what we're doing with the models. Let's just do it together. I'm a little out of it, you can see. I'm not 100% yet, but we do need to meet, so I'm here. I have to find my regression exercise. Okay, so this is the one I gave you. Yeah, everybody has this document, right? And let me get rid of these for a second. So I think I gave you this document like this. Let's see. Well, the one I downloaded. Hold on.
You want something?
Okay, so yeah, I included this twice because we rearranged things. Okay, so let's just take out, we have price, a odometer, age, so let's just delete those. Sorry, I should fix that in the document. Okay, so in terms of the models in the assignment, we're going to justify each one and why we run each one. I have them here. Okay. Okay, and I think the Z statistics videos are going to help you too to understand. So we're going to go with that. Did anybody get started on that already? I did post them pretty late last night, so it's fine if you didn't. Okay, so let's see what I'm sharing here. Sorry, I'm so slow. Okay, so I'm going to put the models in sequence as we go. No, my computer's acting funny. It's weird. All right, so yeah, last class we did draw the model. Somebody's mic is on. Okay. So you guys, everybody uploaded, or sorry, everybody installed the data analysis tool, I hope. All right, I'm not going to repeat that. So what we're going to model now is using that regression analysis and the data tool. Our first model actually was, let's put the first one in, but I called it model 0 because it's not one of our, it's not one of our major models, the ones that you need to submit. So all we did there was odometer and price. All right, so we're going to highlight all the data from price to the bottom of odometer, shift and hold. And I noticed, yeah, you can't see when I hit the menu. Let's see if I can shrink this. But if I hit data analysis, this icon here, that's not going to do it, I think. That's just going to give me some results. Yeah, I don't want that. All right, so at the top, you should be able to hit, sorry, I'm struggling with the Zoom icons. So I want to hit Tools, Data Analysis. You guys can't see that, right? It's not showing up on Zoom. Tools, Data Analysis, and Regression. Can you guys see that? Yeah, you can see that. Okay, so my input range for Y is going to be first, the B to 101, B1 to B101, and C is going to be odometer here. I mean, I'm going to include the label so it has the headings, price and odometer. And I want the results to go into a new tab called Model 0. And I want all these plots. See if you can set yours up. Let me know when you're done. You guys can hear the birds. Got it? Do you guys get it? I'm waiting for you to tell me.
Yes, Professor.
Everybody? So it goes into another spreadsheet. Goes to another spreadsheet where you get all these plots and you get the results to the regression. So let me share that. Oh yeah, you can see it. It opened for you, right? I just realized that. All right, so I'm just gonna kind of make things look better. Make sure everything is visible. I'm gonna move these out of the way. So we assume there's a linear relationship between the two of these, but if we just plot it, and we did that last class, also I'm gonna move this data first. I don't know why things are delaying. It's very strange. Something's happening to my computer. I think my touchpad. I don't know. Oh well, I'll leave it like that then. So if we were just to plot price and odometer, we saw that there was a curve relationship. It wasn't a line. And when we look here, the first plot, this is the odometer reading by the residuals. Does anybody know how to interpret this? What are we looking for? What should we see if odometer is a good predictor of price? What are we looking for? Anybody know? So you guys all have to watch the regression videos. Okay, so what has to happen is so everybody knows what a residual is? What's a residual?
Yes.
What is a residual?
The residual is the difference between the estimate and the actual.
So exactly. So the residual is okay, so it's the y, the observed y of so price minus the observed, sorry, minus the predicted y from the line. And what you expect is that the residuals are randomly distributed. They're normal and randomly distributed around zero. There shouldn't be a pattern in the residuals. There shouldn't be a pattern in the residual plot. So we use residuals as y and the variable odometer, and we see that in the residuals, it's not like that. The data is not, so to be random, it should be evenly spread out all around zero, but it's not. So it means that there's other variables in in the residuals. So in the residuals, that's our error. It's a representative or a prediction of our of the error in the model. And it looks like there's more to it. Okay. So these are actually the residuals here. So it actually calculates for you all the residuals for every observation. So so this is going to be your y predicted. And the the y observed is just the data for price, and that's the residual. Those are the residuals there. Okay. So how do we interpret the results here? Let's see. So we got to interpret the results. We begin with looking at the p-values. Does anybody know how to interpret the p-value here? Let me write a note here. So the residual versus the odometer. How am I going to do this? This here. Okay, so that's how it should be. Residual versus independent variable. Whatever independent variable you put in there should be randomly distributed around zero. Um, okay, let's interpret here. Okay, so what about this? How do we interpret this? So this is the F statistic. What are we testing for?
I believe you're testing for how significant are the results, right? Are reliable or confident?
What does it mean though? What is the F test? So what's the null hypothesis that we're testing? Does anybody remember? Equals what, Raul? So the test is to check that the estimates of the mean or the coefficients are not zero. So the null hypothesis that they are zero, okay? That we only have one variable that we're estimating, and that's odometer. But in general, if you have more variables that you're modeling as as predictor variables, you're going to test that they're all zero. So this is saying the result here tells you to do what? Let me add that this is also like the means. They are supposed to be the means, but I'll just say coefficients. Let's just leave it like that. Okay, so the question is, what does this tell you? What's it supposed to be? So that represents the p-value. And it tells you the chance of seeing the result if the null is true. And the chance is really small. It's really small. What's the smallest it can be? Or sorry, what is small? Let's say it like that. What is small in regression analysis? If a value, if a p-value is less than what? What do we do if the p-value is less than 5%? What do we usually do? I'm trying to pull it out of your brains. If the p-value is less than 5%, we reject H naught, okay? So so the H naught, the null hypothesis is that all the estimates are zero, that there's no impact, there's no influence, there's no relationship. Oh, there's no prediction value. So then we did this test and we're seeing if the test is going to tell us what's the chance of seeing the result we got if the null is true. But the chance of seeing the result we got is smaller than 5%. It's 0.005. So that tells us that um that we have to reject the null hypothesis. It was unlikely of seeing the result if the null was true. So we our null hypothesis is an assumption. So our assumption failed. So we reject the null hypothesis. So it means, in essence, what it means is that this coefficient here is not zero. Notice when you have one variable, your F statistic is the same as the p-value for the t-test. So this is the t-test here. That's your coefficient. We're going to interpret the coefficient in a minute, but first you have to say, well, this is telling us also that it's not zero. Okay, what is this thing here? This is the t-stat, which you convert into a p-value, and the p-value tells you that it's not zero. Negative 18.4586 is not zero. Now, why would negative 18.45 be zero? How could it ever be zero? It's because every value, every coefficient has a standard error. And remember, we have to take every the result here, plus or minus, this is like a mean, right? This is like x bar plus or minus. We're taking or mu plus or minus sigma. This is like our sigma. And we're finding that there's no zero. If we make a confidence interval around this coefficient, zero is not included. If we do it within 95% confidence interval. All right, so this it looks like it's not zero, but it all depends on the standard error, the sigma, to make it zero, and it's not zero. That's basically what we figured out. So that makes it comfortable for us to interpret this here. So we can interpret, and then well, we actually should look at the R first, but we'll go back to that. So how do we interpret this? We say so this is like so for the linear regression, this is a slope. It's a coefficient. This is the slope of the line. And we say for every unit increase in odometer, price, what does price do? Decreases 18 units. So what are the units? Let's see if we can fill it in. So I think odometer, I told you, was kilometers. Let's put kilometers. You're going to say kilometer. For every kilometer, so every additional kilometer, let's say it like that. Price drops or decreases $18. All right, so that's the interpretation of odometer, or yeah. And what about the intercept? How do we interpret the intercept? I keep adding rows. The p-value of the intercept is also very small. So it says when the odometer is 0, price is $6,339 on average. And these results are they're average results because it's over all those different observations. Any questions about what I wrote there? Make sure you write it out and you understand. So the result is, if I was to write this out, the model is y, so it's like y hat, right? Because it's a predictive model, is equal to 6339 plus or minus 18, I'll just leave it 18x. That's what we got. I'm not going to put the decimals. And how good is this model? So this is what we get. This is the model made with a number of assumptions that are reviewed in those ZStat videos. How good is this model? Well, this tells us. What does R squared tell us? It tells us about the linear regression result. And the correlation coefficient, this is the correlation coefficient. If I round it, it's 0.08. What do I compare that to? On a scale of -1 to 1, that's pretty bad, right? It's very close to 0. So even though we interpreted it, it's not a great fit. Everybody following? Everybody getting it? Are we learning something? What is this one? This is virtually that number squared. That's what it is. Okay, so it's the R squared. And this one is interpreted as a percentage. So we say 28% of the variation in price is explained by odometer. So that's not a lot. It's not a lot. It's somewhat. It's something. That's not a lot. Okay, so that's why this was what justifies looking for other variables that explain uh, uh, the price. All right, do I have you guys with the model 0? We haven't even started with the other models. So let's do a few before we go. You guys can work on it today. Okay, so this is not a great fit. So let's do the next model. We're going to call it model 1. And you're going to fit using age and odometer. Can you guys do it? So this time you're going to highlight these three and do the same thing. Tools, data analysis, regression. Let's see if you can do without me. Because we talked about age being influential in the price. Let's include it with odometer. We should first probably do the scatter plots to look at them. Let's do that. That's what we did last class. So let's do price and odometer scatter plot. If I just do this, it does it backwards, right? That's what we found out. So let's so you should always do the 2 by 2 plots to look at them. Like you do it in pairs. So if we have odometer, we already did that, but let's do it again. So insert chart XY scatter gives us this one, but it's backwards. I think it's okay if it's backwards, but let's do it the right way. I have to rearrange these. I gotta I'll just put it in and take it out.
Professor, you can even edit within the chart the columns you want to.
Yeah, you can add it in the chart. Yeah. If I do it like this, insert chart XY. So I can get that one. You can do it with the, like he said, just faster like this. Insert chart. Aha, interesting. So now this is age. What are you going to tell me about age and price? How do you interpret this graph? You see, this has like a quadratic relationship. Now we're gonna model age as though it's linear, but that's not going to be correct either. We have to include this quadratic relationship. And so I'm going to show you how to do that if you don't know. So what does this say? This says initially the older the car, the lower the price. But after a certain age, the older the car, the higher the price. So these are cars that have been maintained as probably as classic cars, and they're good quality cars, and they have a value because they are classic cars, vintage cars. Look at this. This is a 90-year-old car over here. All right. So we're going to model them with the line first, as though they are. So I'm going to do this, and we'll do the curvy one, and then I'm going to talk about something else for a bit because I want you to keep in mind what this what we're modeling. I don't even know. I'm not sure if you know what I'm modeling. Um, because well, let's just do that here. Okay, so let's make let's delete this for now. I don't know, will it disappear if I delete it? Yes, it does. It disappears. And delete this because it's all linked. It's okay. I'll erase them. All right, so let's model price, odometer, and age. Let's talk about the results and let's go from there. So if I do this, if I do it like this, is it going to work? Is it going to stop? Tools, data analysis, regression. Okay. Okay, so I knew when to stop. Oh, it didn't go till D. I need to go till D. I want two variables. All right, and it's going to go into model. I'm going to call it model 1. There we go. We got a bunch of plots. It it puts it into sheet number 1. Let me delete this sheet. All right, so that's model 1 and all my results. Let's look at some drawings here. We need to talk about the probability plot, but I'll do that after. Oh, I got all kinds of things happening. Okay. Uh-huh. All right, so you have to just touch the chart or it doesn't work. All right. Okay, so we still have our plots here. This is not nice and random all around with the mean of 0. It's obvious there's something else going on. Same thing here. It's not exactly random. All right, so what we're going to do, let's start with the R. Okay, so the R went up. R square is better. Okay, so it looks better to include the two variables. Adjusted R square is a little bit different. The fact is, the more variables that you add, R square will go up. The more variables that you add, the R square will go up, and you don't want that to happen. I mean, as a measure of fit, you need to balance off what we say, like a parsimonious model. We don't want to just um, talk about fitting more and more variables because, well, that's not as meaningful as to find the right variables. So this adjusted R square will be a better measure of fit when you add more and more variables. Okay, so this is 0.15. It's better than 0.07. And now this is saying R square is saying we have 41% of the variation in y is explained by those two variables. So that's good. That's better. We still have, okay, so now this is telling us, remember, so going back to everything we talked about before, what model are we fitting now? We're fitting y hat. It's always y hat because remember, it's a scatter plot. It's not a line, right? It is the line is an estimate to the scatter plot. So y hat equals Um, A plus, so we have to put that in. Actually, I didn't even do that over here, did I? Let me go back. What did I put here? Oh yeah, I did. Okay. So let's read it like we did this one. Let's read it off of here. So let's read our results. So our results say that the intercept is now 4615. The coefficient for odometer is negative 23, so it's still negative. It's a little bit bigger. And we're going to call that x1. And the next one, h, is 98, or let's say 99. X2. All right, so that's the model that we got. This one, F tells us, if we remember from here, so it's the same null hypothesis, but coefficient estimates are all zero. This is again rejecting the null hypothesis, right? Because it's so small, the chance of seeing what we saw is unlikely. But we still saw it. So there's something wrong with this null hypothesis. But because it says all coefficients estimates are zero, at least one of them is not zero. So it means at least one of them is significant. So you start with the F, but then you go one by one and see which one is significant or not. That's how it works. Okay. So let me go back here a second. I'm jumping. I'm just copying out what I said this last time. Same thing. So since the p-value is less than 5%, we reject the null, and it means that at least one of the coefficients are not zero. It means it's significant. It means that it's not zero, it's significant. Those are the same. So which one's not significant? Okay, this one, if we go with the p-values for the individual tests, this one's not zero, this one's not zero, and this one's not zero. So they're all less than 5%. So they're all significant. Okay, so they're all significant, they all have meaning. However, our fit is still weak. All right. And what we saw in the plot, so you don't have to always do all the residuals and all these plots every time, but why not, right? Gives it to you. I might as well plot it. Just move them out of the way. What we saw here was that oh no, in those original plots that we made, where we saw the curve, right? Where I saw the curve between age and price. I'm going to introduce a third, well, this is going to be model 2, where we're going to square age. We're going to include a variable for age that's quadratic to pick up on that curve relationship and see if that improves the model. First, though, I'm going to interpret the findings. So let's interpret, and it's going to be similar to last time, so I'm just going to copy it. That's going to be, remember, interpretation. When odometer is zero, the price. Okay, so okay, so this is going to be a little bit different than here because now we have a second variable, right? So how do we do that? So let's make some more space here. No, that's not the space I wanted. Oh my goodness, I'm having such a time here. I don't know why. Something's up with my keypad, my trackpad. Okay, interpretation. Can you guys all see? Is it really small? Do I need to make it bigger? Just let me know. So interpretation, where you begin with the intercept. When? Okay, how do I write this one? Let's see if you guys can help.
One odometer and age is zero, price is 4,650.
Very good. Anthony knows what he's doing. Okay, so when odometer and age are 0, price is 4,616 on average. Okay, so now let's read odometer. How do we read this one? Now, the only difference here is going to be that we have another variable. So we have to include that in our statement.
I believe, I'm not sure if it's in the correct order, but I would write for every additional kilometers in an odometer, with age being zero, the price decreases by $23.
Right. Very close. Not that age is 0, but age is constant. So at every level of age, fixed, if you fix age, okay? So for young ages and for old ages, that's what it's doing. So you say, um, for every additional kilometer of odometer, I guess I have to just stick that in there. The price is $23 less, and you say ceteris paribus, which means holding age constant. It doesn't mean 0. It doesn't mean 0. So if age is 10, and this is like on average, right? Because it's probably not exactly going to be 23, but on average. I'm going to say lower on average, ceteris paribus, holding age constant. So we use the term ceteris paribus, or holding all other variables constant. That's what we say. And age. For every additional year, I don't know how to say this, year of the car, the price is, so it looks like there's a positive relationship between age and price, but that's not even true, right? Because it was going down at first and then up. But this is giving you the average result because the later prices are so overwhelmingly positive. So that's not even fitting the data very well either. For every additional year of the car, the price is $98, $99 greater on average, ceteris paribus, holding odometer constant. All right, any questions so far? So you guys have done this with me. We're going to do one more before we go, and that is going to be the h square. Let's do h square. Go back to the original here. I'm going to put the model 2, which I'm going to refer to, oh, wait. I'm going to refer to as a nonlinear model because we're going to have an h squared term. Now, how do we get the h squared term? Notice we're going to put not just a squared, we're going to put a as h as well. It's not just going to be h squared. We're going to put both. And we're also going to deal with that curve. Remember that curve in odometer? It's like a curvy thing. So to transform, so these are transformations that we're doing. These are transformations to better fit the data to align. So we're going to adjust the curviness of odometer by inverting it. And we're going to deal with the parabola thing of age by squaring it. Okay, so we're going to create those two variables and then run the regression and see what we get. Okay, so you just create new columns with h square and 1 over odometer. And this is going to be fine. You got to be careful with data that has zeros in it. Obviously, you can't take 1 over 0. So you're going to have to be careful about something like that if you ever do a transformation. But you can make adjustments. You can make adjustments for that. Okay, so let's do odometer and then h square. So this is going to be 1 over odometer. But that's not a good way to do it because I need to make them all side by side, right? So let's forget that. Let's do this another way. Let's do it beside price. So I'm going to insert 2 columns and let's put 1 more column. Let's put age. Actually, if I put this here, will it move over? Okay, no. So I got to make 1 more column. So I'm going to put age square, which is virtually a times a all the way down. So you just double click there. And then this one is going to be 1 over odometer, which is 1 divided by odometer. Okay, so these are the adjustments to try and fit it to the data pattern that we saw in the relationship between those variables and price. All right, so then we're going to highlight them. Okay, let me know if you need more time. I hope you're following still and trying to replicate it. If you need more time, let me know. So then I'm going to go Tools, Data Analysis, Regression, okay. All right, make sure it has everything. So the Y is B, and then here I want to go up to E. So I'm going to change that to E. And then labels, and I'm going to go into Model 2 now. And okay. There we go. So let's see. Let's see what our plots look like. These are the residual plots, if they're any better. I wish this would be better. No. No. So I always teach that you have to make graphs first. That's why I'm pulling all the graphs. Aha, this is interesting. Look at odometer. So now we have, it's not exactly random because there's a pattern here between the residuals and odometer. So there's some variable missing that explains that pattern. What about age? Okay, so age and residuals looks interesting. Not exactly random, but it's better, I guess. All right, so there are my plots. There's my output. I didn't do great with moving them around, but let's get this over here. All right, look at this. Wow. What do you think about the results? Did we ever improve the model fit? Okay, so we did a great job here. Now what can we say? Even the adjusted R-square is good. So the adjusted R-square, so this is 0.57. And you compare that to -1 to 1. It's pretty good. Okay, so it's not so bad. It's getting better and it's positive. So there's a positive relationship. Well, I guess we can't interpret because we have three variables now, right? So it's just that it's R is good. And R square says 76% in price is explained by the three variables. So that's not bad at all. Let's look at our F. Okay, this is negative, right? This is e to the -18. That means that it's 2.78 times 10 raised to -18, which makes it like it has 9 zeros in front of, oh, sorry, not 9. It has 17 zeros in front of the 2. Okay, so it's very zero. It's a very, very zero negative. So this is telling us that, again, we reject the null. It means that at least one of the variables is not 0. So it's the same as before by copy out what I said here. Coefficient estimates are all 0. And then all this stuff I was saying here. So at least one of the coefficients are not 0. So now we go and look at each one and we look at them. So these, look at the p-values. They're all smaller than 0.05, right? So everything is significant. All the variables are significant. And let's look at the interpretation. So, okay, we are at time here. All right, any questions for me before I go? So I taught you how to do this. I'm actually thinking of giving you another assignment and making this one due on Friday because you guys should be able to finish this quickly and we're just delaying for no reason, right? But I guess I already made the date. I think I'm gonna encourage you guys to finish this assignment as soon as possible. Now that I hope you have the hang of it, creating variables, interpreting variables, and seeing here that we're improving the model by doing so, by fitting the pattern and the relationship of the variables by transforming them. All right. The intercept is a little bit higher. And okay, so we have to talk about the interpretation. It's a little bit different. So I'm going to encourage you guys today to do the ZStat videos, watch them. He goes through this. He doesn't do the analysis as deeply as I do. He kind of jumps, but you're going to understand it better now that I've given you this introduction. All right, so work with this. Try and finish this before Friday. Don't let this linger, and so I can get into other more. I want to get into economics and finance models. This is an application of regression that's pretty easy to understand, and I thought I would start with this sort of introduction, or I guess review of what you guys should have learned in your statistics class, but you may not have, I understand, or you forgot. Any questions? So work with this. Keep me posted if you have any questions. And I'll work on marking all your material. So you guys have tomorrow off. So you guys can work on this and work on the models. And we'll see you on Thursday. Okay?
Professor, Thursday there's no class. I believe it's Wednesday that we tomorrow.
Oh, Thursday's no class. Tomorrow we have class. Okay. Yeah, I
Yeah.
mixed it up. Thanks, Anthony. Yeah, so we have class tomorrow, but not Thursday, and then we'll have Friday's class. So you guys should be able to finish this by Friday. So I guess yeah, with tomorrow, sure. So get going and get collect your questions for me. All
Do you
right?
have do we have to do a regression for our research?
Yeah,
Is
that
that the assignment for like the next Friday?
no, the assignment for Friday is to finish this. That's the assignment. It's written up on um the assignment 3 in Moodle is this one, the multiple regression analysis, and um this extra set of models that we have to do. That's for Friday. I feel like changing the deadline but it's kind of short. I don't know. What am I gonna do? What am I gonna do? I think I gave you guys too much time for this assignment.
Don't we have to do a regression for our research though?
Yeah, that's why I'm teaching you it, in case you didn't know. Why? What do you
No,
mean?
I thought we had to like upload the regression for our research next Friday. I thought that was the assignment. Like gather the data.
Yeah, that's what I'd like. Hold on a second. Okay, this is for we can I made this due next Friday, but I'm gonna change the date to I can make it to Monday, so you have the weekend. I'll make this Monday, and then the next week we can have the regression for your assignments, or at least some model. If you don't run it already by the next Friday, at least some sort of model, some proposal for the model. Let me see my list. So this is for, I'm going to change this till Monday because I think you guys can finish this before Monday. And then I'm going to, sorry, I'm changing it, but I got to give you some homework. Um, and then let me share. I want to give myself time to read over what you guys have got and meet with you about your research because I don't know if you know exactly what you're going to do next. So let me go back here. So this is yeah, so the research proposals. Oh, look, I have these out of order. That's what happened. That's so funny. I didn't notice. So this Friday you're supposed to have your research proposal. How did I even do that backwards? I don't know. All right. So yeah, I'm going to turn this to the 20th. This one's going to be the 20th, and this one's going to be the 20th. No, not the 20th. I'm going to make it Monday. And then this one is going to be the 27th. All right. So that's going to be for your research proposal, like your regression model that you're going to do, and the critique. So I need some time to get organized for that one. All right. So this is for Monday. The day will be for Monday. Let me see. The 23. Okay, so assignment 3, this will be, it's so funny that I did that backward. 20, and then 23, and then this one will be the 20th. And what I want there, I'll put up what I want from you, just like another assignment. Or I'll say research proposal. So what I want there is the regression model you're going to analyze, where the data is coming from, the what your research question is. All of that will be for next Friday, the 27th. Yeah, I'll fix this and I'll edit the syllabus as well. And I'll post the details of what I expect there. So you're going to have to present yours, and you're also going to have to critique somebody else about theirs. And that's going to be along the lines, remember the critiques that you guys did of that already published paper, that kind of critique. You're going to assess those elements of the research. Okay, that they have a good question, that it's clear that they're filling a gap, that the what the independent dependent variables are, that kind of critique. And the validity of the model. So I'm going to try and match you guys in terms of your research questions. So anybody who wants to change their research question from what they submitted last Friday has to let me know. I'll send an email about it. I need to know by tomorrow. Okay, because otherwise I'm going by exactly what you sent me on Friday as in terms of what your research question is. All right, so I'm going to fix these because I realize they're out of order, and I'm going to email you about contacting me if you're changing your research question. Okay, thank you, Raul, for pointing that out.
Yep.
And we'll see you guys on tomorrow because I mixed up my days again. See you tomorrow, and Thursday's a holiday, the 19th, not tomorrow.
All right.
Okay, bye.
How about